Here we're going to look at Chapter 7, focusing on telecommunications, internet, and wireless technology. So, looking at this slide, we can think about recent developments in networking technologies. Can you give an example of convergence? Think about that. Also, think about how fast is broadband today? In 2000, our typical internet access speeds were about 56 kilobits per second over a telephone line, costing 25 cents per kilobit. Today, broadband speeds reaching 5 to 500 millibits per second and costing a fraction of a cent per kilobit. If I were to ask you how fast your home internet connection is, would you be able to answer that? What about cell phone internet connection? Here, we look at the various components of what a network is, along with those that you will find in a simple network, which we're going to see on the next slide. Can you think about and describe the function of a NIC? What about a connection medium? I'm sure we've all heard the terms before, but think about the purpose for a hub, switch, or a router. Illustrated here is a simple computer network consisting of computers, a network operating system residing on a dedicated server computer, cable wiring connecting the devices, switches, and a router. Although the NOS, or Network Operating System, is shown as part of the server, note that depending on the type of software, a NOS may also be designed to reside on client computers, also called peer-to-peer networks. Here we look at the additional components that we might expect to find in the network of a large company or university that has many locations and thousands of employees. And so we want to start thinking about what is meant by back-end systems. Note that many firms are dispensing with traditional landline telephone networks and using internet telephones that run on existing internal data networks and over the internet. This graphic illustrates the components of a large company's network. Note the difference between the wireless LAN, which allows wireless access within the office, and the mobile Wi-Fi network, which allows internet access to employees outside of offices. The advantage of telephone-based wireless systems is that they do not require a Wi-Fi hotspot to work, and in fact, can connect users to the entire globe through their telephone networks. Cable networks, major competitors of telephone company internet providers, have recently developed a mobile option. So, for instance, Optimum Cable or Comcast has installed neighborhood Wi-Fi spots, allowing cable subscribers wireless access to the internet. This slide, along with the next, look at the main technologies in use today for networks. So, client-server computing, packet switching, and TCP/IP. This slide continues the discussion of the three main networking technologies today, looking at the second, packet switching. Note that circuit-switched networks were expensive and wasted available communication capacity. The circuit had to be maintained, whether data was being sent or not. It is also important to note that packet switching enables packets to follow many different paths. What's the advantage of this capability? If one path is blocked due to an accident or power failure, the data will then automatically be shifted by routers to open paths. However, in truly massive outages like September 11th, nearby metropolitan servers were knocked out, and for a period of several days, internet access was limited in the New York metropolitan area. The notion that packet switching networks would survive a nuclear attack is highly unlikely. This graphic illustrates how packet switching works, showing a message being split into 3 packets, sent along different routes, and then reassembled at the destination. Note that each packet contains a packet number, message number, and destination. This slide continues the discussion of the 3 main networking technologies in use and looks at TCP/IP. Note that in a network, there are typically many different types of hardware and software components that need to work together to transmit and receive information. Different components in a network communicate with one another only by adhering to a common set of rules called protocols. In the past, many diverse proprietary and incompatible protocols often forced business firms to purchase computing and communications equipment from a single vendor. But today, corporate networks are increasingly using a single, common, worldwide standard called Transmission Control Protocol / Internet Protocol, or TCP/IP. TCP/IP actually is a suite of protocols, the main ones of which are TCP and IP. This figure illustrates the 4 layers of the TCP/IP reference model for communications. Note that what happens when computer A sends a message to computer B is that the data that computer A creates is transferred within that computer from the application layer to subsequent layers in sequence. In this process, it is split into packets, and information is added at each stage, ultimately translating the packets into a form that can be transferred over the network interface. After traveling over the network interface, the packets are reassembled at the recipient computer from the network interface layer up, ultimately for use by the application layer. This slide looks at the types of networks that organizations use. Note that a network can be defined by the way the clients interact, so client server versus peer-to-peer, the type of physical medium to carry signals, Ethernet versus fast Ethernet, etc., and the way in which computers are connected and send signals to each other, so the overall topology. A modem is a device that translates digital signals into analog form and vice versa, so the computers can transmit data over analog networks such as telephone and cable networks. This graphic illustrates the differences between digital and analog signals and shows how digital signals can be sent to other computers over analog cables such as telephone and cable lines, which are analog. Note that digital signals are representations of the 2 binary digits 0 and 1 and are represented logically as on and off electrical pulses. This slide looks at the media involved in network transmission. Note that many of the telephone systems in buildings had twisted wires installed for analog communication, but they can be used for digital communication as well. Also, today, telecommunication companies are starting to bring fiber optic cable into the home for high-speed internet access. Here we look at what is the internet. Can you describe it? Can you tell us what you use it for? The text refers to the internet as the most extensive public communication system and the world's largest implementation of client server computing. How do you connect to the internet? Does anyone use a satellite? Note that T lines are leased, dedicated lines suitable for business or government agencies requiring high-speed guaranteed service levels. Do you know what the internet does? Did you know that the internet does not guarantee any service levels and agrees only to make a best effort approach? The domain name system is a hierarchical system with a root domain, top level domains, second level domains, and host computers at the third level. This graphic describes how the domain name system works. Note that the root domain is the period that is used before the top level domain, such as .edu or .com. The internet has many governmental, international, and professional bodies that govern its policies. In addition, many countries have created partially independent domestic internets that are controlled by government intelligence agencies. The concept of a global internet is no longer a reality. For instance, the internet users experience in China or Iran is different from the internet experienced in the United States, the EU, and other Asian countries. This graphic illustrates the architecture of the internet. Note that MAEs, or Metropolitan Area Exchanges, are hubs where the backbone intersects regional and local networks and where backbone networks connect with one another. Here, we start to see future thoughts as to how the internet will evolve over time. This slide focuses the discussion about what the internet is, and here looking at the services or applications that the internet supports. Notice that the internet comprises many more services than just email and the web. Students who might be or who have cable internet telephones are using VoIP or voice over IP. Other popular technologies that use the internet as a platform are voice over IP, unified communications, and virtual private networks. Client computers running web browsers and other software can access an array of services on servers over the internet. These services may all run on a single server or on multiple specialized servers. This graphic looks at the services that an internet service computer can offer. So websites, HTTP, email, SMTP, file transfer or FTP, and news groups or NNTP. It illustrates where on the path between client and backend systems these services lie. This graphic shows how voice over IP works. The voice messages are digitized and transported over the internet in the same packet switching method as traditional internet data. Gateways are simply computers, network devices, that maintain the interface with the internet in a firm. This VPN is a private network of computers linked using a secure tunnel connection over the internet. It protects data transmitted over the public internet by encoding the data and wrapping them within the internet protocol. By adding a wrapper around a network message to hide its content, organizations can create a private connection that travels through the public internet. The graphic illustrates how a virtual private network works. The rectangles A, B, C, and D represent different computers on the VPN. In a process called tunneling, packets of data are encrypted and wrapped inside IP packets. And again, adding that wrapper around a network message to hide its content, businesses then create a private connection that travels through what we identify as the public internet. As you think about your own personal careers, even university, these are just some points that you might want to think about. As many of us are aware that employers certainly do and would have the right to be able to not only manage, but monitor the use of their network. This slide looks at one of the most popular services on the internet, the web, and the main protocols enabling it. The web is an interlinked connection of websites, which are collections of web pages linked to a homepage. These pages are created using a text markup language called HTML and transmitted to users' web browsers by HTTP. Web page addresses, or URLs, are composed of the domain name of the website and the file location of the individual web page. Here we look at how people find information of interest on the web. The primary method is through search engines, which today act as major portals to the web. What are your initial points of entry on the web? How do you find information you are interested in? Many of us will use or be Google users. But have you looked at Bing, which is the Microsoft search engine that has shown some promise? As many of us know already, Google is the most popular search engine. This graphic ranks the major search engines according to popularity or the percentage of total number of searches performed. Obviously, Google is the clear favorite. Is this due to superiority of their search engine results, or does it involve other factors such as their clean interface or their reach, which makes their ad platform more valuable to advertisers? Google's search engine is continuously crawling the web, indexing the content of each page, calculating its popularity, and storing the pages so that it can respond quickly to user requests to see a page. That whole entire process takes about half a second. As we know, multiple options for sharing information on the web. These are just a couple of examples. The Internet of Things includes the idea that our cars, refrigerators, heaters, and air conditioning units, along with all other appliances and buildings, will be on the internet. To some degree, we are already seeing those concepts coming to life today. This slide discusses the evolution in wireless communication. Excuse me. What changes or improvements have happened in your own cell phone service over the past 2 years? Have you purchased or upgraded a cell phone in that time? If so, why? 3G networks, a standard which first appeared in the early 2000s, have mobile upload capacities of about 144 millibits per second, enough for email and some web browsing, but not videos. 3G networks have been supplanted by more powerful 4Gs networks with 5G and upcoming technology. Here we continue the discussion of the evolution of wireless. 4G networks started appearing in 2010 in the US. They are also called LTE, long-term evolution networks. 4G cell networks can be used for display of video on mobile devices with download speeds of about 100 millibits per second and upload speeds of about 50 millibits per second. 5G networks are obviously now beginning to be deployed and will enable movies to be downloaded in seconds. Here we look at the current standards in wireless technology. I'm sure that many of you have Bluetooth or wireless devices that you use for computing, such as keyboards, earphones, or others. Note that in most Wi-Fi communications, wireless devices communicate with a wired LAN using some type of an access point. And here we discuss wireless networking and Wi-Fi. Have you ever connected to the internet through a hotspot at an airport, coffee shop, hotel, other location? I'm sure that many of you have. Are you aware of the security issues of using your smartphones to access the internet at, say, Starbucks? Bluetooth enables a variety of devices, including cell phones, smartphones, wireless keyboards and mice, PCs, and printers, to interact wirelessly with each other within a small, so say 30-foot or 10-meter area. In addition to the link shown, Bluetooth can be used to network similar devices to send data from one PC to another, for example. Mobile laptop computers equipped with network interface cards linked to the wired LAN by communicating with the access point. The access point uses radio waves to transmit network signals from the wired network to the client adapters, which convert them to data that the mobile device can understand. The client adapter then transmits the data from the mobile device back to the access point, which forwards the data to the wired network. This slide introduces one of two wireless technologies having a major impact on business: RFID. Can you think of examples where RFID is used today? The text provides the example of Walmart using RFID to manage inventory and supply chain. RFID uses low-powered radio transmitters to read data stored in a tag at distances ranging from 1 inch to 100 feet. The reader captures the data from the tag, sends them over a network to a host computer for processing. This graphic illustrates how RFID works. Can you think of any potential ethical problems that RFID may pose? For example, if your jeans have a built-in RFID chip, it's easy to track your movements. Likewise, if your student ID card has an RFID chip, so too can monitoring occur. Here we look at radio frequency ID. Think of other examples where RFID is used today. And here we look at the second wireless technology having that major impact on many businesses: wireless sensor networks. Note that the wireless sensors are linked into an interconnected network that routes the data to a computer for analysis. The small circles represent lower level nodes, and the larger circles represent high end nodes. Lower level nodes forward data to each other or to higher level nodes, which transmit data more rapidly and speed up network performance. The graphic illustrates the lower level nodes and higher level nodes at work in a wireless sensor network. Note that the server, the data from the sensors, is sent to act as a gateway to a network based on internet technology.